Hi, do you remember my promise of making an explosive alarm clock? Exploding capacitors. You would have to arm your alarm clock every night. Maybe we can make a magazine that auto-reloads the capacitors for the next morning alarm. 200,000 likes on this video and I'll make that. Today is your lucky day because I'm gonna make that. See? My part is already being printed. So what are you waiting for? Don't you want to increase your electrical knowledge and win your own Keysight tools and scopes and equipment? Because my sponsor Keysight is having their annual event. They didn't change the abomination. That's my landing page. You can sign up for the event from the link in the description. When is the first event? March 14th? That's tomorrow. Sign up! In these absolutely free events, not only you learn electronic tips and tricks from industry experts and engineers, but also you can win thousands of dollars in pro-grade test gear. I'm telling you, sign up. It's free. Anyway, let's design our alarm clock. You know, when my alarm clock goes off, things explode, which are a bunch of capacitors that I have to put in some sort of magazine to feed them through. But I thought instead of a straight magazine like I showed in my previous video, it's better to go with a revolutionary one. And by that, I mean I put the capacitors around something that revolves and connects the legs of the capacitors to the high voltage that is going to blow them up. Let me show you. I designed this 3D model that 10 capacitors can fit in the holes around it and it will turn with a motor. Then we print it. Here we are. Now I can easily fit a capacitor in the holes around it and rotate it. And it is designed to go on a drill so we can easily turn it. Although I don't need this drill, I have the guts of some old drill I can use. Now, how can I hold these things together? Tie them to a piece of wood maybe? Let's test it. There you go. The good thing about running it from a power supply is that I can change the voltage to change the output speed, because I don't know what's the proper speed to feed the capacitors through to blow them up. Let's test it actually. Let's see how quickly the capacitor blows as soon as I plug it in. By the way, this is not a DIY project, don't try this, I'm just fulfilling a promise. Ready? Okay, so it's almost instantaneous. We don't need to run very slow. Now we fit our capacitors into our revolutionary magazine. Spread their legs apart a little bit. Might be beneficial to trim their legs to be the same size too. Now they would have to rotate and touch the high voltage somehow. So I designed and printed this part. Screws go into these parts, held by nuts. Like this, and I'll connect the live and neutral to these screws. Like I said, it's not a DIY project, don't try this at home. Now, what will happen is, as my magazine turns, the legs of the capacitors will connect to the top of the screws and blow up one by one. Now I need to mount these on something. Register, free scopes. Thanks, Linus. There we are. Now when it turns, it should work. Let's just power it up. Okay, ready? By this time, they're all gone. It may need to turn a bit slower though. You know, let's just connect it to live wire and give it a quick try. It's not rotating just yet. All right, You just have to make sure the capacitors are not touching already. Oh, damn it! It seems like the capacitor heated up and welded itself to the revolutionary magazine. I may have to reserve the experimentation for the end product. I guess it would be nice if I could make this part from cast iron rather than plastic, but whatever. Oh, there you go. It's out. Well, anyway, now we need an actual alarm clock to set the whole thing off. Damn it, I don't have a spare alarm clock. We've got an alarm clock. There you go. Now let's see if I can get a signal out of it. Ooh. Look, when the alarm goes off, a voltage goes to this tiny motor here that vibrates that thing. I wonder what is the voltage of this thing. Shouldn't be too much. 1.4 volts? It's just the battery voltage. Let's see if there is an actual switch in there somewhere. I don't know if you see it, but there is a switch here, and I don't know if you can see it at all or not, but if I turn it, ooh, see? That switch closes. Let's lift this thing and see if we can use that switch at all. Oh my god, too much complications. Okay, so it's simple. The negative of the battery connects to one of these white wires that connects to this switch here that enables the alarm. The other side of the switch, another white wire, goes to this yellow wire that connects to this metal spring that is a switch of its own, connecting to a PCB pad here that goes out to the motor, and the other side of the motor goes to the positive side. So you have two switches in series with a motor and power supply. This one enables the alarm, and that one, when the time matches what you set it at, closes and supply current to the motor that rotates and vibrates the thingy. Now I'm thinking all I needed was the access to the contacts of the motor. Didn't need to tear it apart like this. We shall put it back together. Okay, back in business. So we just soldered two wires to the motor leads, red to the positive side, so I know the polarity. Put the motor back in. Seems they already provided a spare hole for me to pass my wires through. It's almost as if I'm making a time bomb. It's just a loud alarm clock, okay? Don't try this at home. Okay, so the plan is simple. We are gonna feed the 1.5 volt coming from the alarm clock through a resistor to a BJT transistor to turn it on, which in turn turns on a relay that powers our motor, turning the capacitor. Let's get soldering. And here's our contraption, minus the live wires, not just yet. So, and that's why we don't have live wires just yet. Anyway, the good thing about having this power supply is that it has multiple voltage outputs. So 5 volts for the relay circuit, 2-3 volts for the motor, depending on the speed we want. And let's give it a try. If I set the alarm clock, well, you already saw it. The motor starts turning, connecting the capacitors to my live wire. There you go. Ready to be tested. Loaded my magazine again. Put it on. Okay, capacitor is not touching. Set the alarm. Good. Turn on the power to the motor and plug in the live wire. And now we just wait. Oh my god, how long is it gonna take? The suspense is killing me. My God, that was violent. Woo. Woo. Shut up. This will definitely wake you up in the morning. It seems like not all my capacitors blew up because my leg adjustment wasn't good enough. But man, I love it. It's such a fun project. Don't try this at home, okay? And I love Keysight. See, my sponsor Keysight makes some of the best pro-grade electronic tools and equipment, and they keep giving back to the community. They create free online education, hold events, and give away awesome tools.
You could have a lab like this for free. Seriously.
This year is no exception, and instead of one event in March, they spread it over 4 events throughout the year. Just check my link in the description and register there for the live event information and educational videos, and for a chance to win that magnificent tool you always wanted. They have always been nice to me and threw in something extra if you use my link to register. There is an additional 2 of these magnificent scopes/function generators to be won in tomorrow's event. And I'm pretty sure there will be more goodies for the next event. You sign up once and it's good for all 4 events. So sign up, it's free knowledge and tools. And may you learn something and win your dream tool. And thank you for watching.